triangles. You can classify triangles by side lengths and angle measures. So in order to classify by side lengths, we need to know the side lengths. Okay, so an equilateral triangle would be a triangle where all sides are the same length. If you had an equilateral triangle, you would also have an equiangular triangle, because if all sides are the same length, then all angles would also be the same measure. Okay, they would all be 60 degrees, each angle, but the side lengths could vary. But if they are all the exact same, then you would have three angles that are exactly the same as well. Now, an isosceles triangle has two sides that are the same length, and that third side can be any length at all. Okay, so if two sides are the same length, then you would have two angles that are the exact same measure. So this should not say triangles, this should just say two angles would also be the same measure. And we call these angles the base angles. Okay, and they're always associated with the sides. So the scalene triangle is a triangle where all three sides are different lengths. And if all three sides are different lengths, then all three angles will be different measures. Okay, so if given a triangle on the coordinate plane, you would first find the vertices and then use the distance formula. And the distance formula, of course, is that formula that says d is equal to the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Now, what we're looking for in this particular section of mathematics that we're studying is the perimeter. And the perimeter of a triangle would be all of the sides added together. Okay, so it's the distance around the triangle. And the equation for that is simply the perimeter is equal to side A plus side B plus side C. So again, if given a triangle on the coordinate plane, you first need to find the vertices, and then you would use the distance formula. And the perimeter of the triangle is all the sides added together. So the perimeter, again, is the distance around. And here's your formula. Now we can determine the angles of a triangle by using the Pythagorean theorem. If the Pythagorean theorem, which is a squared plus b squared equals c squared, and if it actually does equal c squared, then you would have a right triangle. Now you can also determine if it's a right triangle by the slopes, because if you found the slopes of each side of the triangle and you notice that the slopes of two sides were opposite reciprocals, then you would know right away that they are perpendicular to each other, which means that you have a right triangle. If a squared plus b squared does not equal c squared, so we need to add a does not here, does not equal c squared, then you do not have a right triangle. It's pretty straightforward. It must be that side a squared plus side b squared equals c squared. Okay, now you could have an obtuse or an acute triangle, and an obtuse triangle is where you have one angle that's greater than 90 degrees. And if that's the case, then you would have an obtuse triangle that could be either scalene or that's probably it. Or you could have an acute triangle. And for some reason, I'm having issues spelling tonight. I apologize for that. But you could have an acute triangle. Okay, and if it is an acute triangle, you would say that a squared plus b squared, if a squared plus b squared is greater than c squared, then you have an acute triangle. And if a squared plus b squared is less than c squared, then you would have an obtuse triangle. Okay, and we'll work with that a little bit more. But you can use the Pythagorean theorem for more than just determining if it is an exact right triangle. It can also be used to determine if it's an obtuse or an acute. Okay, so the Pythagorean theorem, one more time, is a squared plus b squared equals c squared. A will always be your smallest side of the triangle, b is the middle length, and c is going to be your longest side. If we're talking about an actual right triangle, a and b make up the legs of the triangle, and C is the hypotenuse, always. Okay, and again, you can determine the angle by using the Pythagorean theorem. If a squared plus b squared does equal c squared, and this is just a repeat of what was on that last page, then you have a right triangle, and if a squared plus b squared does not equal c squared, then you do not have a right triangle. But if it's greater than c squared, then it would be acute, and if it's less than c squared, then it would be obtuse. So let's take a look. If we look at this red triangle here, triangle ABC, your first step would be to determine what the vertices are. And my vertice, my A vertex, is located at the point -12, +11. Okay? B is at the point 2, 10. And C is at the ordered pair of -6, +4. So I went ahead and did a little screenshot of it so we could write on it as we go. And here are my ordered pairs. So your first step is to use the distance formula. And if I use that distance formula, we're just going to find the distance between A and B. Okay, so the distance between A and B, I start by writing that formula. So I have x2 minus x1 squared plus y2 minus y1 squared. Okay, and if I'm using A to B, I'm going to let A be my x1, y1, so B is going to be my x2, y2. So if I substitute this into my equation, I have that the distance is equal to 2 minus a -12 plus 10 minus 11. So 2 minus a -12 is a +14, so I have 14 squared plus 10 minus 11 is -1 squared. So 14 squared, I believe, is 196. Is 196. Plus a -1 squared is +1. So I have the square root of 197. And again, remember, we're talking about a distance, and so this is going to be in units. But let's just write that in there for right this minute. Okay, so this is approximately, and if we want to round, we can round to the nearest hundredth. Remember, that's your second decimal place. And that would be about 14 and 4 hundredths. So 14.04 units. Okay, so now you need to do the same thing for A to C. Okay, so I'm going to let, if A is x1, y1, I'm going to let C be my x2, y2. So when I rewrite my formula, I have x2 minus x1 squared plus y2 minus y1 squared. And then I'm going to substitute in my given information. So I have -6 minus a -12 plus 4 minus 11. Extend this line here. So I have -6 plus 12 is 6. And 4 minus 11 is -7. So that's going to be 49. So I have 36 plus 49, which is 85. So the square root of 85. And that is approximately 9 and 22 hundredths units. Okay, and then I need to do the same thing now for BC. So if I do this for BC, I've got x2 minus x1 squared plus y2 minus y1 squared. Okay, I'm going to let b be my x1, y1. So I would say -6 minus 2 squared plus 4 minus 10 squared, which would be -8 squared plus -6 squared, or 64 plus 36. And these are all the square root, which is the square root of 100, which is 10 units. Okay, so from here I can find the perimeter because I have all of my three distances. Okay, so I know from B to C is 10 units. I know that this is the square root of 85 units, and so I can add up all my sides. So I can say that the perimeter is equal to, I could say the square root of 197 plus the square root of 85 plus the square root of 100, or I can just use the decimal equivalencies here, but when we add all these together, we get that this is 14.04 plus 9.22 plus 10, 33 and 26 hundredths. 33 and 26 hundredths units. Okay, so that would be my final answer for what is my perimeter. Now if I asked you, if we look at this, and we can classify this triangle by the side lengths. None of our side lengths are the same, so this would be a scalene triangle. Okay, so this is a scalene triangle because no side lengths are the same. And we could determine what our, we could also determine if this is acute, obtuse, or right by squaring our side lengths and determining. So if we do that, we can see that our smallest side length is the square root of 85. So we would say the square root of 85 squared plus 10 squared plus, or what kind of relationship does that have with the square root of 197 squared? Okay, well the square root of 85 squared is simply 85, and this is 100, and then we've got 197. And so we can see that 185 is going to be less than 197. So when our a squared plus b squared is less than 100, or than our c squared, we can go back and take a look and see that when it's less, that we would have an obtuse triangle. Okay, so if we have an obtuse triangle, this would be an obtuse scalene triangle. Triangle, G-L-E, there we go.